Welcome back, dear students, to this other video on floating point number representation. The A part has been explained very well. Now we are moving to the B part of the question, which says the B part, sorry, of the explanation, which is all about converting from floating point binary number to the equivalent number in decimal. And as you are in one of the most when it comes to advanced level computer science 795, two different methods are being used here, just like for the A part of this concept. Two different methods are being used here to explain to you how to convert floating point binary numbers to the equivalent decimal number. Converting floating point binary numbers to decimal numbers. One way to convert a floating point binary number into binary is to use the expression mantissa times 2 to the exponent and evaluate each part of it, taking into consideration that both the mantissa and the exponent are represented in 2's complement. This can be evaluated in two different ways. One, evaluate the mantissa and exponent each in decimal, then multiply the result as mantissa times 2 to the exponent. By shifting the binary point, that is, this is the other method, by shifting the binary point, the mantissa represents a value with a binary point between the two most significant bits, because remember, positive numbers 0.1 and so on, negative numbers 1.0 and so on. The exponent determines how far to float the point to determine the final value of the number, which is later then converted to decimal. These are the two different ways. Let us look at some examples. A system stores floating point numbers in normalized form using 7-bit mantissa and 5-bit exponent, each in 2's complement. Calculate the decimal equivalent of the following floating point numbers. So this is the A part. As you can see, extract the exponent you are starting from the right. That is the first 5 bits represent the exponent, and the rest represent the mantissa. So this is what we have as the A part, and we allow the mantissa is the exponent 11000. As you can see, then the rest is the mantissa. And since the first bit is 0, it means that it's a positive number, and we know that positive numbers are of the form have as mantissa 0.1 something. That is what we have. Method 1. What do we get? I convert the mantissa first of all, and since my mantissa is 0 point something, means that it is positive, and we know that to convert a positive number into its complement to the equivalent decimal number is just like converting a binary to decimal. And the place values, we have -1, -2, -3, -4. We don't consider 0. So when we convert that, we get our mantissa to be 0.9375. The exponent, when you convert the exponent, the most significant digit is 0, so it is still positive, and when you convert, you get 3. So now method 1 asks us that when you have the mantissa and the exponent, you simply obtain the decimal equivalent using this formula, mantissa times 2 to the exponent. So that is what I have. So my number is going to be 0.9375 times 2 to the power 3. When you use a calculator to punch, you have as answer positive 7.5. Method 2 suggests that having the exponent being 3, as you see, means that what? The decimal point need to be shifted 3 times. And take note, dear student, do not be confused. In conversion from the decimal to the floating point binary, shifting towards the left implies a positive exponent, and shifting towards the right implies a negative exponent. But see, this is the contrary now. Having a positive exponent means that what? I will be shifting toward the right, and having a negative exponent implies I'm going to shift towards the left. So take note. Now, so the number is obtained by shifting the decimal point on the mantissa 3 times to the right, because the exponent is positive. And this is our mantissa here. So I'm going to obtain the number by shifting this point 3 times. So my mantissa is this. When I shift 3 times, it makes my number to be what? I shift 1, 2, 3 times. So I'm going to have 111.100. So I simply convert this number now to decimal, and this is what I have. Place value 0, 1, 2, as you can see, the -1, making it to be 4 plus 2 plus 1 plus 0.5, and our number is positive 7.5. So those are the two methods we have in converting a floating point binary number to the decimal equivalent. Let us look at the B part. That is the number we have. Mantissa positive, exponent negative, because the exponent start with 1. So method 1, I convert my mantissa normally. It gives me 0.75. My exponent is negative, and they are stored in 2's complement. And we know that to convert a number in 2's complement, we saw that there are two methods. Yes, But one of the most used method is by complementing it back, that is by doing the ones complement of it, then add 1 to the result. And if I do that, sorry, I instead use the second method, that is by taking the most significant digit to be negative, as you can see. So I have negative 2 to the power 4, then 2 to the power 3, 2 to the power 2, and 2 to the power 0. This one is not considered because it is 0. So I get negative 16 plus 8 plus 4 plus 1. Take note, dear students, that normally the negative is supposed to be outside. Yes, the negative is supposed to be outside. That's why I have negative 16 and not 16. The negative is supposed to be outside. So it gives me negative 3. Another student could still proceed by saying that you put this in one's complement to have 0, 0, 0, 1, 0. And now when you add 1, it will give you 0, 0, 0, 1, 1. And when you convert 1, 1 to decimal, you have 3. And this first digit implies that our sign is negative, so it still gives you the negative 3. Now, my number is mantissa times 2 to the exponent, so I'm supposed to have 0.75 times 2 to the negative 3. You punch that on your calculator, you have as answer 0.09375. If I use, you can use method 2 to verify that this answer is actually correct, because having an exponent of negative 3 means that what? From this mantissa, you're supposed to shift the decimal place 3 times towards the left. Yes, you're supposed to shift it 3 times towards the left, and then you convert back the result. You will still have this answer. Now, the C part, we realize that our mantissa is negative and our exponent is positive. And in this case, I'm going to use method 2. I first of all convert my exponent, and I see that my exponent is 5. So my number is obtained by shifting decimal place 5 times towards the right. So my number is going to be 1, 2, 3, 4, 5. So I have 101010.1. That is what we get. From there now, what am I going to have? I convert it to decimal, and since it is the most significant digit is 1, it means that what? I will take it to be negative, because in 2's complement, if my most significant digit is 1, it means that it is negative. And hence, to convert a negative number already in 2's complement to the decimal equivalent, one of the methods is by considering the most significant digit to be negative already. So negative 2 to the power 5, the place value here is 5, because this is 0, 1, 2, 3, 4, 5. So I have the place value 5, 3, 1, and negative 1. So my answer is going to be negative 21.5. You can use method 1 to verify that the answer is actually legit. The D part is what we get, and we see that our mantissa and our exponent are both negative. If I use method 1, what am I going to get? My mantissa, yes, I consider it to be negative. So I'm going to have negative into 2 to the power 0, 2 to negative 2, negative 3, negative 4. At the end, when I add, it will give me negative 0.5625. The exponent, when you convert, you have negative 1. From there now, you use the formula number is equals to mantissa times 2 to the exponent. So my number is actually going to be negative 0.5625 times 2 to the negative 1. And when you punch, you have your number to be negative 0.28125. So that's what we have, dear students. I use all the different cases where the mantissa and the exponent are both positive and negative, and when they are of different signs. I hope through this method you can now convert a number which is expressed in floating point number, which is specified number of bits for the mantissa and the exponent, to get the equivalent binary number. Do not forget to like, to subscribe, and to share for our community to grow, and see you in the next video, where we shall see how to normalize a binary number into floating point. Thank you, and see you in the next video.